Welcome to my talk. My name is Karsten Silz, and I'd like to tell you today why picking technologies and tools is faster by doing that with Jhipster coding. So if you want to see the mind map or give me feedback, or you want to start yourself with Jhipster or subscribe to my newsletter, then you can go to this URL, or you can just take a picture of this QR code with your smartphone. I'm going to show this slide again at the very end, so I'll just move on. So my first thesis is that Java developers today regularly pick more technologies and tools. And my second thesis is that we pick technologies and tools faster by coding with Jhipster. So let me start proving my first thesis, talking about technologies and tools. So what was our life as Java developers 10 years ago? Well, we had a backend and we had a front end running in our app server, accessing the corporate database. So you were either a backend guy or you were a front-end guy. There was also QA, ops, support, but we didn't care about any of those. So what's our life now? Well, the first thing that happened is microservices on containers. And what they did is they took away our app server and they took away our database. So now really we are on our own. So we've got the freedom and the duty to choose. Do we go monolith or do we do microservices? What kind of application framework do we use? What kind of database? Okay. Next thing that happened, full stack developer. So what does that mean? Well, it means that we're now doing the backend and the front end at the same time. So the backend guys, asking, well, JavaScript, CSS, what's that? And the front end guys saying, well, how do I write business logic? And what's a transaction? Okay. So the next thing that happened is shift left. Well, what's shift left? Well, let me show you. So yep, really we're doing QA now. We're doing testing. So how do we do that? How do we do continuous integration? Well, and then another hit is DevOps. What's DevOps? So yep, we're doing the whole shebang now. We're doing everything, coding, testing, running, and supporting this stuff. Well, that clearly must be the end. Well, unfortunately, it isn't. Single page applications, those nifty JavaScript applications that Google made popular with Google Maps and Gmail. We're now doing those too. So the impact is that we still have our Java application, but it's a backend now. And the front end is now a completely separate application, a web application, a client. So we got to pick a framework and we scratch our heads and ask, well, how do we build this? How do we test that? And then mobile apps happened. So instead of one client, we now have 3 client applications. And so for mobile applications, we ask, do we use web apps? Do we build native apps, cross-platform stuff? How do we test this? How do we monitor, gazillion apps running on different phones? And the last thing is cloud components, because we can take a lot of the components that we have, like database monitoring, testing, and pay somebody else to worry about it. Do it in the cloud, not do it in our environment. So that just throws another wrench into our engine here. So just as a reminder, we went from this place, where we either were the front end or the backend guy inside our application server. We are going to this place where we now have, 4 applications that we have to worry about. So I hope you agree with me that, yes, we really have much more technologies and tools. So that means we can scratch off the first part here and now look at this, regularly. What does it mean? Well, do we get releases and alternatives regularly? Let's look at the releases first. We started out with Spring Boot once a year, popular framework. Now we get it twice a year. Java used to come every 3 to 5 years, and now it's also twice a year. And a language like TypeScript, pretty popular in the web area, they have a release every 2 to 3 months. Your language, your programming language updates every 2 to 3 months. But you also get more alternatives here. When we look just at Java, before we had Oracle and IBM. Well, we still have Oracle, but we've got all these new guys popping up here. So from 2 to 7, 3.5 as many sources for Java. And the same is true for application frameworks. We used to have just Oracle Sun Java Enterprise Edition and Spring Boot. They're both still around, but new challengers have entered. So we've got, we went from 2 to 6 frameworks. So I hope that you agree with me. Yes, regularly we get many releases and lots of alternatives. So that means I think I proved my first point. And well, now it's your turn. So I'd like you to vote. Well, it's not that we haven't heard enough of voting these days, but my question to you is, compared to 5 years ago, do you pick more technologies and tools in your Java projects today? So how can you vote? Well, you can vote by scanning this QR code or going to this URL and typing in this code. So I'd like to encourage you to do that now while I'm waiting for the results. So please pull out your smartphone, scan this QR code, and go to this URL and vote, please, yes or no. I'll give it a few seconds. So please go to this URL and vote. Okay, so we've got 1 here who said yes. We've got 2 who said yes. 3, so voting is going to close in 10 seconds and no recounts. 4, 5, 6. Okay, and the voting booth have closed. And as you can see, 6 people voted and all said yes. Wonderful. So that means you agree, yes, Java developers today regularly pick more technologies and tools. Now, how do we actually go about picking technologies and tools? Well, it first starts with the analysis. We look at the candidates, figure out, do they work? Do they scale? Are they popular enough? What's the risk of using them? And then we look at the code and say, well, how do we build? How do we test? How do we debug? How do we run it through continuous integration? How do we deploy it? How do we monitor it? How do we support it? How can we use our data? And the most important question is, how productive can we be? So, lots of questions. And remember, we have to research this for all of these things, right? For 4 applications, we have to answer all of these questions. Now, when we say we need to, how can we learn about these technologies? Well, there's a number of different ways. We can read articles, we can read books, watch videos, listen to talks, like this boring one. We can do online training, on-site training, we can hire consultants, or we can run code. So those are all the options that we have. So what are, common issues with learning about this stuff? Well, we often find outdated code, Medium article from 2 years ago that doesn't even compile anymore, incomplete, toy examples. And if we hire consultants, that's expensive. And as a result, what we get, what we can get from the stuff out there from learning is often hard to debug, to run through continuous integration, to deploy. And, unless we pay somebody, it's going to be tough to get our data into these samples. So really, we have a dream. And the dream is that we could develop the application multiple times with each candidate. Let's say we've got React versus Angular. Why don't we write the application twice, once with React, once with Angular, and then we say which one is better? Or, Postgres versus MongoDB. And we'd like to use our data for that, and we'd like to do that for free. And of course, we can't have that. Or can we? Well, let's hold on to that question and just say, yes, we actually do struggle to pick technologies and tools because of all these questions for all these technologies and tools. So that means for my second thesis, we've got the first part, checked off, and now we're actually getting to today's main event, Jhipster. Okay, making an entrance here. About Jhipster because we pick technologies and tools faster by coding with Jhipster. Very subtle here. So what is Jhipster? One way of thinking about it is that Jhipster is a superstar developer who picks technologies and tools, configures these, and updates them along the way. And this guy also writes all the plumbing code, the production grade code that we are often too lazy to write, data transfer objects, all these business layers. So that's one way of looking at Jhipster. Now, under the hood, really, Jhipster is an open source code generator. It creates full Java applications and web applications. It doesn't create mobile apps, but Java and web, front end and back end. Now, what does it do? Well, it does exactly three things. Number one is it generates an application. And that includes user management, tests, continuous integration, deployment, monitoring, batteries included. It can also generate CRUD, create, read, update, delete screens. We can import our data model, and then we get front-end and back-end code. And finally, it updates our application. So it regenerates the application and our entities, the front-end and back-end code. And so we get to use the latest version of our Java libraries like Spring Boot or the latest version of Angular. So we can keep our application up to date and safe. So what kind of technologies and tools does it have? Well, we can build monolith or microservices with Jhipster. We can generate Spring Boot. That's where it started, but it also supports Micronaut, Quarkus, even Node.js and .NET. It creates relational database code or NoSQL code, imperative, like the typical servlet code or reactive, or we can build front end in Angular, React, and Vue. Now, with any open source project or with any project, you ask yourself, what's the risk? So Jhipster has been around for 6 years, steady releases throughout that time. It doesn't have any proprietary layer, and that's a key difference to projects like Grails or Rails. So there is no proprietary view layer, no proprietary persistence layer. It's really just best practice code. So, once you generated an application with Jhipster, you can just, never use Jhipster again, just maintain the application as a well-written Java web application. So let's take a look at one more thing. The project lead now works at Microsoft Azure, is an evangelist there, but there's a healthy list of committers. So I think from that perspective, it's a healthy project. Now let's look at the weekly downloads as a sign of popularity. Here we can see that over the course of the last 6 years, it trended up. And right now we're at about 40,000 downloads a week. Now, how does Jhipster actually help us? Remember, we had this slide here where we said these are all the questions that we need to answer when we pick tools and technologies. Well, Jhipster helps us. First of all, it picks. Jhipster picks candidates. And so what it means is we don't have to worry about the candidates. And Jhipster only selects candidates that work, that scale, and that are popular. We still have to analyze the risk ourselves. And because Jhipster generates application, we can indulge in our favorite activity, which is copy and paste. So where can we copy and paste? Well, Jhipster creates these fully running applications for us. So we can copy and paste how to build an application, how to test it, how to run it through continuous integration, how to deploy it, how to monitor it. Okay, that's good. But there's more. We can actually use the application that Jhipster created. It's a fully fledged running production grade application. And then we can do two more things. Number one is we can actually debug the application. And number two is we get to use our own data. Okay, so if we look at that, we see a lot of the questions that we have and all of the tasks that we have when we pick tools and technologies, they are a lot easier when we use Jhipster. Okay, but there's one more thing, which is, we can learn from unknown code. Now, what do I mean with that? We don't need to know a technology inside out to answer some of those questions that we saw. We don't need to know how React works in order to debug it or to deploy it or to monitor an application, right? And because Jhipster creates these applications with these unknown technologies, we can answer some of these questions already. So let me give you an example. I generated 2 applications with the same data, but different technology. So the first one is Angular and SQL, and the second one is React and NoSQL. I've never worked with React and NoSQL, so let's see what I got here. So here is an entity, a Java entity in NoSQL, and here's the, sorry, there was SQL, and now we have it in NoSQL. And what you see is there is no difference because I've only shown you the code. That's the same. So the blue stuff is the same. Now, how does NoSQL entity differ from SQL entity? Okay, here we go. So we see we've got some annotations and we've got a type for our product here. And you see here is the SQL entity, and we see a lot more red and more annotations. And the one thing that is different, we see here the data type, right? So here the ID is long. For NoSQL, it was a string. So that's really the one difference. But the rest of it, is pretty much the same. So that's where you can go, well, okay, even without knowing MongoDB and all this stuff, I look at my entity and I say, well, that ain't half bad. Yeah, right. You can probably use NoSQL. Now let's look at a screen user interface, React versus Angular. It's the adding a product screen. Here's the React code. Here's the Angular code. And again, I've just shown you the code that's the same. Now the red code that you see here is the one what's different. What you see here in Angular, it comes from a template file. And you see we're using standard tags here, standard HTML text. We've got a span, we've got a button here. Okay, now let's look at what that screen looks like in React. And there's 2 things that stand out. Number one is at the very top here, we see code, because in React, you can mix separate concerns, business logic and presentation in one file. So the code file contains the layout as well. So mixing those concerns. And the other thing we see here, we don't use standard tags. So instead of A for standard HTML link tag, we only see link here. So that's really the difference. And so when we compared it with Angular, we would say, well, maybe I like Angular more. It's keeps concern separate and it uses standard HTML text. And I think I'm more productive with Angular. So that's what I mean when I say that, yes, we can actually, get results from looking at code, even if we don't know all the underlying technologies. Okay, so, and if we come back to the dream that we have, we can really say, yes, the dream is alive with Jhipster. Why? Because I've shown you we can develop application multiple times with each candidate, as I've done here, React versus Angular, NoSQL versus SQL. We can use our own data, as I did just in the example, and we can use it for free because Jhipster is open source. And so once more with feel, we're picking faster by coding with Jhipster, which means that hopefully you're now convinced too, my second thesis is correct as well. And so now for the very last time, if we pick technologies and tools, we pick technologies and tools faster by coding with Jhipster. Boom, there we go. Subtle as a used car salesman. So if you like the talk, then you can go to this link or to this URL and this QR code and take a look at the mind map, got some more details, give me feedback on my presentation, learn how to start with Jhipster, or subscribe to the newsletter. Okay.